I'm Sarah Jensen, editor of OEM Off Highway, and welcome to Design and Engineering Insights. Today I'm speaking with Jim Zwicka, Director of Manufacturing Solutions at Vertex. Thank you for joining me today.
Thanks for having me.
This month we're kind of looking at engineering tools that help with the development process for engineers. So I was wondering if you could maybe kind of provide an overview of Vertex's remote 3D collaboration platform, how it works, and what benefits it offers.
Yeah, I'm happy to do that. So Vertex was built out of career engineers. And so even back in the 90s, we built one of the first collaboration tools, you could say, by enabling massive amounts of geometry to be viewed in a single session. And ultimately that solution became the industry standard, and it's been used for the last 20 plus years. We realized though that with the demand of having enterprise-wide access to massive amounts of information, digital twin is a term that's we've been using for with different phrases for a very long time, but it's become kind of mainstream. But what it really implies is that you have everyone in the enterprise and the extended enterprise, so suppliers and service technicians, have access to a digital representation of the product that they're working on, so that they can then use that as a basis to communicate and connect everyone together. And so Vertex was really founded because we knew that the solutions that we built back in the 90s were not positioned well to actually leverage that. And so that is why we've started this company, and we completely rethought how collaboration is done with massive amounts of 3D geometry to enable that very connectivity.
Mm-hmm. Okay. And so what differentiates this platform from other collaboration tools that are available in the market?
Yeah, that's a very important question. The solutions that we built really were the frameworks to which you see many of the software solutions and hardware solutions today. Namely, what happened with there's a heavy device dependency on all of the solutions today, and there's a heavy software component, not to mention a learning curve. So those three things. So if no one's buying a $5,000 computer for someone in procurement, or a $20,000 software seat for them as well. And then if you're an infrequent user, you're not going to want to go in and try and learn a complex solution just to have access for something that you need quickly access to. And so what we did is we built, again, when rethinking how visualization is done, we eliminated the hardware dependency, so you can actually access massive amounts of 3D geometry on any device, whether it's your phone or your computer. We put no burden on that hardware. You don't actually need the software in it either to view massive amounts of information. And the learning curve is very small. In fact, the thing that we've built is a platform to which you can build your own user experiences very easily. So you can take all of this data and really kind of contextually present it to the right people in the right way, without all of the heavy sort of work it required historically to prepare it so that they can see it that way.
Mm-hmm. Okay. And so with the helping the learning curve, then would that benefit if somebody is new, or like a newer engineer to the industry or something? Would that benefit them? And
yeah, the key here is it could take 6 months to a year to become very proficient in today's legacy product lifecycle management tools, ERP tools, that sort of thing. Quite frankly, we didn't think much about user experience, user interface back then. Mm-hmm. But now what we did is we created a platform to which you can build your own web interfaces to it, so that going back to, say, a procurement or a service technician example, they don't need to go into the engineering tool to see what they need to see. They can get a experience that's more aligned to a service technician need and workflow versus having to kind of adjust their life to look at the user interface that an engineer uses. So we put that flexibility in there to build those right experiences. And so we try and eliminate the learning curve that way by giving them what is familiar to them. It just happens to be enhanced by having 3D visualization inside.
Okay. All right. And so what types of information and data sources would this platform be best suited for using?
Yeah. So generally speaking, when you talk about an enterprise, we have, engineering data tends to reside in the engineering space. Manufacturing data tends to reside in the manufacturing side. Service, procurement. So you have essentially the familiar term of siloed information that really in the aggregate is what the enterprise needs to make good decisions. However, there's significant value in, for example, someone in marketing knowing what engineering is going to be building, or a service technician having access to some richer engineering information to help them, make good decisions. And so what we have available really is, so if you think engineering, all of the native CAD information is available. It gets converted into a 3D model. And then if you have all of your ERP or so enterprise resource planning or manufacturing execution systems or the technician information, all of these special information, I guess you could say, that they would have needed that they house in their space can be aligned to that 3D geometry and then actually made available across the enterprise. So those groups can still work in their world, in their silo, but all of that information is now aligned to the 3D geometry and then made available to them that way. So they're able to see it.
Okay. So it could really be used across the spectrum at a company of the various departments, possibly.
It's the whole point of this is, and if you want, I can show you a little bit of a quick demo if you want to hop in and see.
Sure, that would be great.
Okay, so some examples of contextual use of information that traditionally wouldn't be made available to them. Them being, I'll talk about a service technician, for example. So, so there's multiple sources of data here. In fact, we have a native CAD geometry, which I'll just go ahead and open up. So you'll see that it's running in a browser right now. I do not have a CAD system on this machine at all, and we don't put any software on your device. So this is running through a browser and only a browser, but you have access to 3D geometry. And what you would do, for example, as a technician, you may be working on this digital twin, we'll call it, that we're looking at. I could hop into this part here. I may say, this is the part that broke. I need to be able to see it quickly. I could just show only that part. I may want to put a section on it. So here's the key, is that generally speaking, the technician having the ability to use a digital twin to quickly find that part that they need to get replaced, they have this ability now to, with this twin, we go ahead and pick this part, find this, save a snapshot, and then they can quickly talk to, let's say they're out in the field and this thing is broken down. They need, as we know, it's very expensive on downtime with respect to off-highway equipment, thousands of dollars per hour. But they could quickly, with their phone, take this picture of this part with their digital twin and then immediately connect to their procurement team or to the service team back at the base, or maybe even back to the OEM, to be able to say, hey, I need this part. So they could just quickly go submit that. And then through this platform, it would say, hey, I know that for this part specifically, these are the groups that need to be able to see it. They'll immediately be notified that someone out in the field has this issue. They would know exactly what part they need. They would be able to see sizing if they wanted to. And then they could even collaborate back and forth if they wanted to work together to see what that part is, the timing, all that sort of thing. So, and that's one use case. A couple more that we have here, just since we're here.
Yeah.
When you hear about digital twin, there's another phrase that also comes in, which is called the internet, like IoT, Internet of Things, which implies that you could take actual sensor data that's being gathered from the machine and then apply it actually to the twin. So this is a wind turbine. You can see that, I'm gonna go ahead and open this up. You'll see that we have sensor data that's aligned here. And what I'm gonna do is I'll just quickly hop through. And if you look at the background, you'll see that the sensor information actually is doing what we call a material override of the parts, so that they can see, this line of data might be kind of confusing, but if you see, but based on the inputs here, some of these are now red, which means there could be a failure issue going on. So it allows you to quickly and easily take different sources of information, bring it together, and then be able to quickly understand, do I have a problem here or not, based on what's coming in. And this allows you to just do, as a human, visual representation aligned to 3D images is really very powerful. And so that's what we're doing here as far as bringing those together.
Okay.
I'll just do one more example, another service tech example. Like, let's say I'm working on this car, and I should say all this information is coming straight from engineering. So generally a technician would not have access to a 3D representation of their product. But I could take and align a user experience with Vertex that all we're doing here is we're embedding into the solution. And we're giving them 3D geometry aligned to their traditional user experience. So as I work my way down, you'll see that every selection I make here reduces this down and actually brings in a camera swoop. They would have traditionally worked here, but not had a visual representation of their product. But I now, with Vertex, I could come in and say, well, what is this part? And you're able to pick that part, view it, and see right away, okay, oh, it's that part, here's the part number, this is how many I need. Oh, okay, cool. And it allows you to have a visual aligned 3D representation versus traditional textual representation, so that you can quickly and easily go, yep, that's the thing I need. Boom, I'm gonna go ahead and order that now. And so these are examples of our the Vertex platform embedding into solutions that are user experiences that are traditionally there, but we're enhancing them to align visuals to make things much more accurate based on having a 3D versus just a textual representation next to it.
Okay.
All right.
And so can this be used on any type of piece of equipment or system or component?
Yeah, so we didn't, let me explain what's happening here. So while I do this one last sort of disassembly process. The big differentiator between Vertex and the traditional solutions out there is that all the other companies will actually push all of this geometry to your device. So it relies on the device to be relatively heavy, thus the hardware dependency. Vertex, what we've done instead is our cloud platform actually understands that this is the geometry that you need to see. As I tick through these pieces, you'll see I'm doing an assembly process where you can bring in pieces and the pieces come in where they're supposed to come in. But as opposed to sending the geometry to your device, what we do is we compile an image and stream it to your device to give you the impression that you're working with 3D geometry. But all that's actually happening is we're giving you an image to the device in sort of a movie form to make you think that you have access to the geometry, but all that's really happening is you're getting an image that aligns to what you've asked it to show and present.
Okay.
So that part of it, by the way, also brings up, it opens the door to a much more secure solution. Oftentimes any information that is sensitive, you could say, to a company gets locked down very heavily.
Right.
But in our case, this is all an image that's being delivered. You have full traceability of the content, so you know who's looking at what and when, and you're not actually giving them a 3D copy of the geometry to their device, which then they could do some things with. In our
Hmm.
case, all we're sending is a single image, and they have no ability to measure or reverse engineer those parts,
Okay.
because we're only giving them an image to view as if they have access to the geometry.
Okay. So then are you guys finding that, especially now with more people working from home or, remotely, is this type of, are you seeing a growth in use of this type of technology or foresee it continuing to grow or?
Yeah, most companies that we've worked with were using legacy engineering tools that we had discussed before, the kind of doing it the old way. Um, and so since the pandemic and everyone working from home, the thinking that they had the tools they needed to collaborate correctly have been stress tested pretty heavily, and they've realized that, in fact, what they thought was a good collaboration solution has turned out not to be the case. Um, and so we've seen a big uptick in interest from us, because they realize that if everyone's working from home, uh, we have discovered the device dependency and the internet connections and the security that we're concerned about aren't, are falling over because of the solutions that we have.
Mm.
And so they've come back to us, or they've come to us and they said, you know what, the way you guys are doing it actually is much more aligned to doing collaboration and extended collaboration um, than what we thought. We thought we were good, we're not. You guys have actually you're doing this the right way, because in essence you're streaming a movie versus pushing gigabytes of data around in a risky way,
Mhm.
and the experience is much better. And some companies have even said that the only way they can view their massive machines across during the circumstances is by using us. They can't use their legacy tools, they have to come to Vertex to do their collaboration
Mhm.
events. So it's been very good for us.
Okay. Well, great. Okay. Well, those are all the questions I had for now. I don't know if you had anything else you wanted to add or thought people should know about Vertex or the technology.
Yeah, we're all seasoned engineers. We've lived the life of pain of trying to connect data together, and we built this platform literally to address the barriers or the problems that companies have had viewing information securely and connecting groups that have never been connected before. And we're very happy with what we built. All of our customers are very happy with what we've given them. And yeah, we're here to really connect everyone with data that's never been connected before. So we're happy to do that.
Great. Well, thank you very much for joining me today. I appreciate it.
Thanks for having me.